One of our example maps and water materials is our ocean water. And we can see here it tries to simulate a rocking, rolling motion with waves. And on the top of the higher waves, we have a little bit of a seafoam effect. Now, this is using tessellation, and it's using the height of the water to determine where those seafoams should go. And of course, we have the normal options we can change in the bottom right, such as how high our water waves go, how much foam there is, and things like that. If we were to take a look at the material, it's not too complicated. The majority of the material is broken up into how much noise there is, or how noisy or wavy our actual ocean is, and then determining where are the tops of those peaks in order to apply our seafoam. You'll find throughout this material, they're using the motion four-way chaos node. This node basically makes four-way chaos or four-way random noises so that way you can take that value and use that to drive other information. In this case here, we have how big our large waves are going to be. And in the top left, we have how big our small waves are going to be, how much motion there is for our large waves again, as well as the scale or how much seafoam there'll be. And all of these are driven into a set of lerfs that determine how much of each based on the parameters we set up. At the end of our wave and motion and seafoam chain that we can see here, it takes all of our values of our waves, our small waves and our large waves, and lerfs them together based on how much of each we want. And then our final lerp, which we can see here, this is plugged into our large wave motion, which we saw again from the beginning. And based on how much height we want, we'll determine how much of that foam is going to show up. Now, I did mention before that this uses tessellation in order to give us that wave effect. If we were to unhook our tessellation, and then we go back into our water itself, you can see it's now flat. We still have those large waves and those small waves. We still have some seafoam. However, it's not actually expanding our water or making it look like it's going up or down using tessellation. I've gone ahead and got back in and hooked back up tessellation, and now we can see how our mesh itself is being displaced or moved up. Our vertices are being adjusted in real time to give us this wave effect. Now, if I change our tessellation factor to 0, you'll notice that our wave lines, so we have an orange line along the back, look more rigid. They're more straight, they're longer. There's not much variation, and it almost looks like our wave is stuttering. That's because tessellation adds extra data to our mesh itself, and that is what determines how smooth it's going to look. So if I increase our tessellation back, now you notice our lines are a lot more smooth. We have a lot more data between each original line. It's adding extra data. Now, here's one thing to note. With the upcoming release of Unreal Engine 5, tessellation is being deprecated. There is going to be alternative solutions in the future, but for something like this, we might have to adjust to world position offset. I mentioned before that we were basically creating extra information on our mesh using tessellation. Unfortunately, if we're going over to world position offset, we no longer have our tessellation multiplier working. World position offset is going to work with the original vertices or the original setup on our mesh. Because world position offset uses the actual data inside of our mesh, and we're not adding it like with tessellation, in order to get more smooth movement, we want to add more data or more vertices inside of our original mesh. So just keep that in mind. You may need to create your original source meshes more densely in order to get a better effect when using world position offset.